going to discuss when the function can be called discontinuous or continuous, but we're going to be focused on the discontinuity. If the left and right-handed limits exist and have the same value as the function itself, then there are no breaks or holes in the graph. We call this function a continuous function. But if this condition fails, we call it a discontinuous function. So the types of discontinuities are removable discontinuities, sometimes we call it point discontinuity, jump discontinuity, some other times we call it jump or gap discontinuity, and then infinite discontinuity. So now we're going to take each and every type of discontinuities and we're going to discuss them in details. So we start with removable discontinuity. A removable discontinuity occurs when the limit as x goes to a exists, but the limit of f of x does not equal to f at the same value. So what we do is to check the limit as x goes to 3. From the right hand side, the limit is equal to 3. From the left hand side, the limit also equal to 3. So the left and right handed limits are equal to each other. That means the limit exists. But the function's definition as x goes to 3 is this point at 5. So they're not equal. So that's what we call a removable discontinuity. The other example is if we take a look at x equals 3, the function is not even defined at x goes to 3. So there's a little hole we call a point or removable discontinuity. So the second type of discontinuity is called a jump or a gap discontinuity, as you see in the figure. And this happens where there's actually a clear gap between parts of the graph. So in here, we can say the function is not continuous at x equal to 3 due to a gap discontinuity or a jump discontinuity. The third type is called the infinite discontinuity, and this happens when one or two parts of the graph is going to infinity, or when you have a vertical asymptote, as you can see in the figure. Same thing here, both parts of the graph are leading to infinity as x goes. Let's see an example on finding the points of discontinuity. So first we have a function f of x equal to 5 when x is less than or equal to 3, minus x plus 7 when x bigger than 3. And the question is this function continuous at x equals 3 or not? And if not, we need to describe any discontinuity. We have 3 steps to find if the function continuous or not continuous. The first thing, we need to find the f of 3 or the function's definition at 3. Step number 2 is finding the limit as x goes to 3 positive, that's the right-handed limit as x goes to 3. And step number 3 is the left-handed limit as x approaches 3. So first we substitute in the function with 3. But be careful, we need to choose the part of the function that x is actually equal to 3, which is the upper function. So as you can see, the function is equal to 5 as x equal to 3. Step number 2, we find the limit as x goes to 3 positive. And 3 positive means slightly higher than 3. So we're going to go for the x bigger than 3. So it's the lower part of the function. So f of x equal to minus x plus 7 as x bigger than 3. So this limit as x goes to 3 positive will be minus 3 plus 7, which is going to be equal to 4. Step number 3, to find the limit as x goes to 3 negative of f of x. However, we don't need to do that since the function's definition is equal to 5. The limit as x goes to 3 positive is actually 4. They're not equal, so even finding the limit as x goes to 3 negative is not going to be important at this point. So we know now that the function is actually not continuous at x equal to 3. Now let's take a look at this graph. We graph the function 5 where x is less than or equal to 3, which is a constant graph. And then we graphed minus x plus 7, which is a decreasing straight line with a slope of negative 1. And as you see, we have a jump or a gap discontinuity.